All right, so we're going to talk about carbohydrates and how exactly we can use this food that everyone loves, or nutrient that's found in all these foods everyone loves and is eaten in overabundance, and how we can incorporate them to actually help us reach our goal. And then we'll actually talk about exactly kind of what they are, how they're used. All this good stuff surrounding carbohydrates. So, some questions we're going to address are: what the heck are carbohydrates? What do we use them for? What exactly happens when we eat them? How do we actually use the stores of carbohydrates in our body? How we use the carbohydrates after exercise? And then we're going to get kind of practical with it and talk about what foods exactly we are going to need to eat, when to eat these foods, and then what amount should we be eating them in, which is kind of something that is the biggest important thing is though if we get the food and the timing right, the poison is still in the dose. We still have to eat the right amount. We can't overindulge in carbohydrates or really any food in any way because too much of anything can be a bad thing. That's pretty universal. Okay, so what exactly are carbohydrates? For our purpose, from a biochemistry standpoint, they're a carbon-based molecule rich in hydroxyl groups, which hydroxyl groups are just these little alcohol OH oxygens attached to hydrogen atoms bonded to a carbon molecule. So that being said, they have a lot of different structures that they come in. Typically, most dietary uh, carbohydrates are typically sugars, and typically sugars exist in a lot of kind of ring formation, which we don't need to talk about that, but just understand that they have a lot of diversity in the way they are structured, and they come in that the carbohydrates, when we talk about them, we talk about the ones we get from our diet, but from a whole like biology approach, uh, that there are much more bigger things that fall under the category of carbohydrates than just the sugars or the things we consume in our diet. Um, so, but on the basics, they're just a lot of carbons with hydroxyl groups attached to them. Uh, so what exactly do we use these carbohydrates for? In our purposes, in our discussion, we're talking about dietary carbohydrates. So we're talking about using them for energy and using them to store energy. Um, and that's essentially what we're going to talk about. Now, they do have a lot of other functions besides that, and that's because of all the structural diversity they have. They can form all these different kind of shapes and compounds which can lend themselves to other things, but we don't really need to talk about that because it doesn't relate to our goals. But for us, the primary function is energy and energy storage. So what we need to talk about first with this whole carbohydrate thing is exactly what the heck our body does with them when we eat them, and why can this be bad and why can this be good. So the first thing that happens is digestion, and this image isn't exclusive for carbohydrates, but it just gives a good overview of a lot of the structures involved. And so the first thing that happens is we eat a food that's laden with carbohydrates or has carbohydrates in it. Begins to be digested in our mouth, goes down our throat or our esophagus, goes into our stomach. Okay. Once it's in the stomach, our stomach acids dissolve it. Then it begins to move through our intestines, gets broken down more. Now the bulk of sugars get broken down in our small intestine. Okay, and this is when they get cut up and turn into the simple sugars. The basically they all get turned into glucose. Is essentially, regardless of what kind of source you're getting at. Like if it's milk, it's lactose. If it's table sugar, it's fruit or it's sucrose. Those are just combination sugars, but they all get broken down into our body into their basic forms, which is glucose, galactose, or fructose. But for the main part, it's glucose. That's what we think about when we think of sugar. That's the simplest form of sugar. So that's what we're going to talk about. So they get digested. They get put into the small intestine. In the small intestine, chyme, which is it's hard to describe. It's just a material that helps break down these carbohydrates. Once these carbohydrates are broken down into the component sugars, the glucose is then absorbed through the small intestine. That's how the glucose gets from your mouth, your stomach, your intestine into your actual bloodstream, and then from there, it's shuttled. The glucose is then shuttled from the bloodstream into the cells of our body. The vascular, the blood is the kind of the highway that nutrients use, including carbohydrates, is the highway we use to get things to particular parts of our body through the blood. So that's where the glucose has to get to first. So it's broken down in the stomach, broken down more in the small intestines, and then ultimately absorbed in the small intestine. Okay, so after absorption, it goes into the blood. Okay, and in the blood, you hear about people talk about their blood sugar level. That's the free glucose floating around in our bloodstream. And blood sugar is a important thing because we need to keep our blood sugar regulated. We want it to stay at a good level. And this is not only important just for nutrition, but it's also important for a lot of physiological functions. Diabetics have all kinds of other health issues because they can't regulate their blood sugars very well, and they're usually very high. And high levels of blood sugar is bad. It's dangerous, and it can cause damage to other parts of your body. So once in your bloodstream, what happens is the glucose is then metabolized, and the way it's metabolized is it comes out of your bloodstream and gets pulled into cells and tissues, and that happens by the glucose being diffused across the membranes of your tissues. And then when that glucose, well, let me back up. That's not the whole story. So the glucose is in your bloodstream. When you eat something, okay, and something is digested and absorbed in your intestine, your pancreas recognizes the sugar, and the pancreas secretes insulin. We've all heard of insulin. Insulin is the regulatory hormone for glucose uptake. So when we take in glucose and our body senses an increase in blood sugar in our bloodstream, the pancreas then is stimulated to release insulin. And insulin is what binds to our cells and allows the glucose to be transported into the cell, which is where it gets metabolized. So to actually use glucose for energy or to be able to store glucose, we have to get it inside our cells, and the body does this through insulin. Insulin's released, insulin binds the cells become permeable to glucose, and glucose is then transported with the aids of proteins across the cell membrane into the cell. Once in the cell, that's when the magic happens. That's where the actual metabolism, the actual utilization of glucose happens. So this picture right here, if you just focus on the green, for now, that's what we're talking about. Is once the carbohydrates are in your cell, they go through a process called glycolysis, which for a lot of people you probably have heard this term, but the first step in getting glucose to go through glycolysis is you got to prevent glucose from leaving the cell. So the way you do that is an enzyme comes along and it phosphorylates, and that's what you see there in the green, the glucose 6 phosphate there. By putting that phosphate on the glucose, it prevents the glucose from leaving the cell, and then that way the glucose can actually be put into glycolysis and used for energy. So glucose then enters glycolysis, which is just a process by which glucose is converted to pyruvic acid. And in the process of converting glucose to pyruvic acid, we produce two ATP molecules, and ATP is the cell's energy currency. That's what any kind of function or reaction that takes energy, the cell uses APT to supply the energy. So we need ATP, and that's how we use glucose to derive ATP. Is we take glucose, we digest it, we put it into our bloodstream. Insulin allows it to be pulled out of our bloodstream and into our cells, and then convert that glucose in our cells into pyruvic acid. And in that conversion process, we get two molecules of ATP out, which is good energy for our cells to use for other things. And that's on a cellular level, but that 2 ATP helps facilitate all these functions in our body. Not just the two molecules, but ATP in general helps all functions in our body, which eventually leads to us being able to move, run, jump, think, all that good stuff. It allows us to do the things we need to do. Now, the good thing about glycolysis is that glycolysis allows us to use sugar for energy, and it's a really rather quick process, and it's a process that can be done in the absence of oxygen, and that's a good thing, because there are times when we don't have enough oxygen to be able to carry on to the further steps of metabolism. So it's a great system, and it's an important one, and it's not a bad one necessarily. But what happens is that when you take in glucose and your body doesn't need that much glucose, it gets basically, you take in a bunch of glucose, insulin spikes, insulin pulls that glucose out of your bloodstream in an effort to regulate your blood sugars and keep them low, which is good. But what it does is then it pulls it into the cell and puts it through glycolysis, and we get ATP out of it. But then it gets turned into pyruvic acid, which then then crosses into the mitochondria of the cell, which is kind of like your powerhouse of the cell, and it gets converted into acetyl-CoA, which you can see there's that second to last green circle there from the bottom of the image. And then acetyl-CoA, though, what's bad about that is that it can then go through a process called lipogenesis, which is basically the formation of fatty acids from glucose, essentially, because that acetyl-CoA can be formed through glucose as well as fat. But if we're eating a lot of glucose, then that acetyl-CoA is coming from the glucose. And then if our cells, such as in fat cells, if the cells that the glucose is being upregulated into doesn't need the glucose to drive energy or to meet energy demands, then it goes ahead and uses that acetyl-CoA, it gets converted into fat. Because fat is a much better storage molecule for glucose. Energy. For energy. So our body, being the efficient thing it is, it chooses to store energy in an efficient way, which fats are an efficient way to store it. So the excess glucose that isn't going to be used for energy immediately then gets shuttled into being stored for fat, which is bad. The other thing, though, that happens to glucose is it gets stored as glycogen, and glycogen is basically just long chains of long chains of glucose attached to each other. And this glycogen is stored in our muscle cells, and it's stored in our liver cells primarily. And our body can hold only a certain amount of it, and once that certain amount has been reached, we then start shuttling all the glucose that comes in that we can't store as glycogen, we shuttle into storing it as fatty acids if it's not used immediately for cellular needs. And this is not good. We don't want more fat stored. We don't want glucose stored as fat. So if our glycogen levels are always up and high and we never have to replenish our glycogen stores, most of the glucose that comes into our cells is then used to make fatty acids and store it as fat on our body, which we don't want. We don't want more fat on our body. We want less fat on our body. Okay? So the way to limit this is to make sure that our body can use the carbohydrates that come into our cells to replenish the glycogen, the carbohydrates that we eat that get turned into glucose. We can use that glucose to do one of two things. We want to make sure our body can use it to either repair or meet cellular demands immediately, or it can use it to replenish glycogen stores. And the problem is, though, for most people, is that on a resting basis, in an inactive lifestyle, our glycogen stores are never depleted, and our cells are never under a really high demand for repair, for cellular needs. We can meet those cellular needs through oxidative metabolism of our fat. So we just end up storing that glucose as fat for a rainy day. So the strategy is just to keep glycogen levels low, replenish the glycogen levels, and then limit the amount of glucose we take in while those glycogen levels are high. And that's essentially what our dietary strategy of eating a low carbohydrate diet does for us, is that we're still able to train hard, because after we train hard, we can then eat glucose, repair or restore the glycogen that was just depleted through the training, and then we can start again, then limiting our glucose intake. So, and this is all talking about the body at rest. This is all process that we just talked about is while you're at rest, because while you're at rest, your body prefers to use fat as its main source, because fat can be oxidized. It gets turned into fatty acids, get catalyzed into acetyl-CoA. Acetyl-CoA can go straight into the Krebs cycle, and through the Krebs cycle, oxidation of the fatty acids yields way more ATP. It's way more efficient to produce ATP than is glycolysis. Glycolysis produces 2 molecules of ATP. The citric acid cycle, the oxidative process of fatty acids, produces 38 molecules of ATP. That's way more. It's way more efficient. It's way more productive to spend that time producing or taking the time to oxidize fat than it is to source all our energy from glucose. That's why we don't store a lot of glucose in our body, because it just doesn't yield a very high energy intake. But we store tons of fat, because fat can be oxidized. One molecule of fat can be oxidized to 38 ATP. It can yield tons of energy. The difference, though, between glycolysis and oxidation of fat is that oxidation of fat takes much longer than glycolysis. That's why our body shifts to using less carbohydrate at rest and more fat for fuel at rest, because we have the time. We're not under immediate demands to meet a lot of energy output, so we can take the time to go through that oxidation process and yield all this ATP. Now, what happens, though, is we use those stored glycogen levels when we shift our environment to one where oxygen is in short supply and our blood glucose level is being depleted. And that describes the situation that we are in an intense exercise. So, as we were just talking about, the body prefers to use fat for fuel at rest. And as that intensity level of activity shifts from rest to more intense, the body shifts its source of energy from fat to carbohydrates. And that is because, or glucose, carbohydrate, glucose, we're talking about the same thing. Glucose can be metabolized much faster than fat can be oxidized because it's a simpler process. And when we're in a situation where we're trying to meet cellular demands immediately, and we're trying to maintain our blood glucose because it's glucose is being uptaken by our cells to meet cellular demand, we're trying to keep that blood glucose level regulated. Our body shifts to sourcing from those glycogen stores in our liver and our muscle. So we hack off one of those glucose molecules of the glycogen, and we put it through glycolysis, and we get our 2 ATP, and we meet the energy demands of the cell that are happening in this really intense period of a lot of energy, a lot of work's going on. The other thing that happens is that our body becomes incapable of oxidizing fat because the process of oxidizing fat requires oxygen, and if our body is limited in its oxygen intake, we can't oxidize the fat. So we have to find another way to get ATP when we can't use oxygen, when we aren't taking in enough oxygen to meet the demands of the cell. As in when we're sprinting really fast, running really fast, lifting weights, doing something that requires a lot of effort in a very short amount of time, we're asking the cell to do a lot of work, to use a lot of energy, but we're not taking in very much oxygen at the same time. So your body switches to a process that doesn't require oxygen, such as glycolysis. So we feed on these stores, and so since we're also taking sugar, the circulating glucose in our bloodstream, we're pulling it out into our cells, putting the glucose through glycolysis, getting our energy. That lowers the glucose level in our bloodstream. So our body then takes glycogen from our liver, takes glycogen from our liver, secretes it into our blood cells, and that upregulates the glucose in our bloodstream. And then that glucose can be transported to other tissues that are needing the demand, other cells that are needing the glucose for energy. Glycogen is also stored in our muscles. So when we're doing some kind of strength training, we can also source glucose out of the glycogen in our muscles. So the glycogen is already inside the cell, and what the cell does is it breaks off a glucose off that glycogen molecule, puts it through glycolysis, and gets its ATP. But what happens is after a 60-minute hard bout of training like we do 3 times a week, at the end of that 60 minutes, we've severely have depleted our glycogen levels. We're very low on glycogen because we've used all that glucose to power all that work we just done in the gym. This is where carbohydrates come in handy, because as we were talking about earlier about the digestion and the metabolism, the digestion, absorption, and metabolism of carbohydrates is that our body takes these carbohydrates in, and if we don't need them, then we store them as fat. But if we do need them, then we go ahead and metabolize them into acetyl-CoA, and we use these glucose for energy, and then we also use the glucose to then store the glycogen, to form the glycogen that we store in our muscles and our liver. So after exercise, our body is mainly using these carbohydrates to repair cellular damage that we just did to our muscle cells through exercise, through resistance training. And then we also use most of these carbohydrates that we eat right after exercise to facilitate the replenishing of those glycogen stores. So very little of the glucose or the carbohydrates we take in after exercise will be put to stored as fat, because our cells are going to need them to replenish glycogen. They're going to need them to repair. That's why we can use carbohydrates to reach our goals. We can still eat those good not good foods, but those foods that we love to eat and think taste good, that are those processed, fast digesting sugars that would be bad at any other time, to still reach our goals if we use them after our exercise. Now, how much exactly we want to take in is the question after exercise. So let's just to sum it all up, because I tend to ramble, don't do a very good job of keeping my thoughts in order. So to summarize, the basics is that at rest, when we take in excess glucose, when we take in large amounts of glucose, insulin spikes, causing glucose to be taken out of our bloodstream, because we just take a huge amount that got digested and absorbed, and our body responds to that. We don't want our blood sugar in our bloodstream to be high. We want it to be at a stable level. So your body regulates that through insulin. So it releases insulin. It shuttles the glucose out of your bloodstream and into your cells. Well, if you're at rest and your cells don't need a lot of energy, and they're meeting and you have plenty of oxygen available to you, and you're not short of breath, your body's then going to take those glucose molecules. It's going to put it through glycolysis. It's going to get the 2-ATP, and then they're going to have this leftover pyruvate that's going to be converted to acetyl-CoA. And if your body's already getting plenty of acetyl-CoA from fatty acids, it's going to take your acetyl-CoA and turn it into fatty acids, because it still wants to be able to use that acetyl-CoA that it derived from the glucose. It still wants to get all the energy from it that it can. It just doesn't need it right now, so it stores it as fatty acids, which can then be used on a later date. So that's how eating large amounts of sugary foods on a regular basis all day long is bad and leads to excess fat accumulation, because your body doesn't need all that excess fat. It's got glycogen stored up already. It's good on that. It's already meeting its energy demands from the excess fat you already have on your body, so it's got no need for the glucose to come in. It just doesn't need it right now. But what happens is that after exercise, you've depleted your glycogen, and your body is not meeting its cellular demands through just oxidizing fatty acids. So it needs glucose. It needs glucose now, because glucose can be turned into energy fast, and your cells need repaired now, and they need to replenish the glycogen now. They need to get the glucose in your bloodstream up again, because it's just been lowered because we just sucked it all out to meet the demands of the cells involved in exercise. So that's the reason why carbohydrates are not always bad. They're typically not the best choices during most parts of the day, but immediately following exercise, they can be one of the best choices for what the body is demanding. And that brings us to really the question most of all of you want answered, or more specifically we want to address for our goals, is that what foods do we want to eat, when do we want to eat them, and in what amount? And so the first thing we're going to address is that we hear people talk about the glycemic index. And the glycemic index is basically just a way of telling us which foods are digested really slowly and which foods are digested really quickly. And we base that off of how quickly the blood sugar levels rise after eating a food. So, let's say you're going to eat a chocolate bar, right? That's a very high glycemic food. Your body is going to recognize an increase in blood sugar levels very quickly after taking that in, so it's rapidly digested. Whereas something like a sweet potato, for example, is a very low glycemic food. Maybe not real low, but moderate. And so your body is going to increase in blood sugar very slowly. It's not going to recognize such a fast increase in blood sugar. And that's good because your body responds to increases in blood sugar. That's when it releases insulin. If you have a huge spike in blood sugar, your body's going to release a huge amount of insulin to compensate. So you don't want to be dumping fast digesting carbohydrates into your system all the time, because your body's constantly then going to be spiking insulin. Insulin's going to pull the glucose out of your bloodstream, and then it's going to put the glucose into your cells, and then the cells are going to turn the glucose into acetyl-CoA, which acetyl-CoA can then be stored as fat. So the more these simple digesting, or the slow digesting carbohydrates you eat, the more insulin release, the greater the glucose uptake, and then ultimately the greater the storage of fat, especially when you're at rest. However, though, low glycemic foods, such as sweet potatoes, they don't result in that really high blood sugar spike and insulin spike. So a food like a sweet potato, right, goes into your system, it gets digested slowly, the blood sugar rises very subtly, so that you don't get this huge shuttling of glucose out of the bloodstream and into the cell, and then all this glucose being converted into fat, because your cells don't need all that glucose to meet the energy. It's already been met. So in that situation, while you're at rest, you don't want to take in high glycemic index foods. Hold on a minute. Let me check myself on that. You don't want to have, I can't remember if it's low glycemic or high glycemic. But the better way to put it is slow versus fast digesting. If the food is a fast digesting food, then you don't want to be, or a fast digesting carbohydrate, then you don't want to be taking in that fast digesting carbohydrate while you're at rest, because most of that glucose is going to get shuttled into fat storage rather than put into glycogen stores and used for energy. Whereas you would want to eat large amounts of fast digesting carbohydrates after you exercise, because most of those, especially after you perform a high intensity, not so much low intensity, but high intensity weight bearing exercise, you can eat a lot of carbohydrates, because your body is going to take those carbohydrates, use them to restore the glycogen levels in your liver and your muscles that you just depleted, and it's going to use some of that carbohydrate to meet the energy needs to repair the cell and overcome all the damage you just did to your muscles. Now, slow digesting carbohydrates are exactly the opposite. You want to eat slow digesting carbohydrates when you're at rest, because that's going to mitigate the insulin release. It's going to mitigate the amount of glucose from that food, from that broken down food, that's going to be stored as fat. But you don't want to eat slow digesting carbohydrates after you exercise, because slow digesting carbohydrates are not going to be able to be used to replenish your glycogen and repair the cell, which is what it wants right now. Slow digesting foods after exercise are going to do the same thing as they would do before exercise, is that they're going to break down really slowly. They're going to put into your bloodstream at a really slow rate. Your body's going to not repair the cell. The cells aren't going to repair as fast. They're also not going to be able to use a lot of that glucose to be stored as glycogen, because it's not being shuttled into the cells immediately as it enters it, because it takes so long to get the blood sugar to rise up to create an insulin release. So if there's not a great enough rise in your blood sugar to secrete a lot of insulin to get that sugar into the cells, it does no good after exercise. So the thing to take away from this entire talk, and what I was hoping to try to give you a little bit more insight, is that all carbohydrates are not bad, and carbohydrates just have to be used as a tool in our attempt to reach our goal. So to wrap it all up, we want to use slow digesting carbohydrates at rest within our low carbohydrate scheme. So we want to still hit our number that we're looking at, or particularly my idea is always to try to minimize the amount of carbohydrates you take in anytime other than after exercise. So if you're going to have to eat carbohydrates or need to eat a carbohydrate you feel like during the day, you want to pick one that's a slow digesting carbohydrate. For fast digesting carbohydrates, you want to use them after exercise, not during just any time of the day. So you could wait and save that scone, or you could wait and save that whatever it may be, pasta, rice, whatever you want to say that fast digesting carbohydrate that you love is, you could save that for after your exercise and eat it then, so that glucose is then used to help power your goal and not be stored as fat and take away from your goal. So that's the end of the kind of the presentation part of it. So we're going to talk now about some of the actual foods on the list I gave you guys at the beginning of this whole thing, which is on the screen now. Which, if we look at the starches there's quite a few starches that we can use that are slow digesting during the day. And the reason why I just list the slow digesting is because those are the ones that most people have a hard time finding ones they like, or finding different options for them, because they tend to only know those simple fast digesting carbohydrates. So, for example, like something like our sweet potato, right? That could be something you have at dinner, something that you could have at lunch. Same thing with tortillas. Same thing with quinoa. Or sorry, not quinoa. I think it's pronounced. I have no idea how it's pronounced now that I think about it, but I'm gonna keep saying it quinoa, whatever. The point is that these foods, potatoes, wheat bran, rice, beans, oats, rice cakes, all these things can be eaten anytime during the day except for after exercise, and not negatively affect you towards your goal. Now that doesn't mean you're going to eat sweet potatoes all day and hope to lose fat, because your body works on a spectrum. You're still going to be shuttling whatever glucose you take in to fat storage in some amounts, but we're trying to mitigate that by using slow digesting foods and eating a little low amounts of glucose, or low amounts of carbohydrates, so we have low blood sugar levels and low stored sugar levels. So once again, you can use all these foods on this grocery list any time of the day. Now, the foods that you love to eat and that aren't on this list, and the foods that you crave all the time, are the foods that we want to save for after our workout. Those are our pastas, those are our white breads, those are our white tortillas, those are our simple sugar. Those can even be as simple as the dextrose found in most candies. That's a great source of post-exercise carbohydrates. But you could save those quote-unquote bad foods that are bad all the rest of the day, and they turn into good foods after you exercise. So that I hope this kind of gave you guys somewhat of an overview of kind of what carbohydrates are, how we use them, how they can be used to help us and not hurt us, and then gave you some ideas for how to structure your carbohydrate intake so it helps your goal. So to sum up, the way you would do that is you would use fast digesting carbohydrates after you exercise. You would use the slow digesting carbohydrates, the ones that I gave you on your grocery list, during the rest of parts of your day, all within the scheme of low carbohydrate diet, minimizing the amount of sugars we're taking in on a daily basis. So on a non-training day, you might spread out your carbohydrate intake with all those slow digesting foods throughout the day and hit your number of carbohydrates for the day. on a training day, you might save up all your carbohydrates, or a large portion of them, of your carbohydrates, a large portion of that intake, and you might save it up to have a fast digesting carbohydrate after you train. Anyways, I hope that this kind of gives you guys a clearer picture of why we're eating the way we are, or why I'm coaching you to eat the way we are, and how this is going to help your accelerate fat loss and prevent fat loss, or prevent fat storage on your body, and help take fat off your body. As well as, I hope it kind of gives you guys a little sense of relief that you don't have to give up all of the carbohydrates in your world, that you can actually use some of them to help towards your goal. So you don't really have to sacrifice these foods you love. You just have to use them at the appropriate time in the appropriate portion. And that's something that we will talk about on an individual basis with each one of you whenever you feel like it. If you want to know, what exact amount should I be eating after I work out, or what exactly amount should I be eating throughout my day, that's something that we can talk about on an individualistic basis. But I hope that this overall talk gives you some hope that you can still have carbohydrate foods, high carbohydrate foods, and hit your goals. So have a good rest of your day. I'll see you guys on Friday. Talk to you later.